Assalamualaikum warahmatullahi wabarakatuh. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala sayyidina Muhammadin asyrafil mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wa hlul 'uqdatam min lisani yafqahu qawli. Allahumma zidna ilman warzuqna fahman wa amalan shalihan wa taqabbala. Ya alhamdulillah, syukur pada Allah SWT. Hari ini dengan limpah kurnia Allah SWT kita dapat bertemu dalam kuliah secara online melalui live YouTube. Itu tajuk untuk subjek EB025 Basic Engineering, iaitu tajuk 1.5 moment. Jadi kita terus ke tajuk. Baik, sebelum kita tajuk, sedikit kata-kata hikmah. A'udzubillahi minasyaitonir rajim. La yukallifullahu nafsan illa wus'aha. Allah tidak memberati seorang melainkan apa yang terdaya olehnya. Dari surah Al-Baqarah ayat 286. Maknanya kita, sebenarnya Allah tahu kesanggupan diri kita, apa yang mampu kita buat, maka Allah tidak memberati kita melainkan apa yang kita terdaya. Jadi kamu pun sebenarnya berdaya, sebab tu kamu dapat hadir ataupun kamu menjadi pelajar kolej matrikulasi. Okey, kita terus kepada slide kita. Okay, this is a nail immersed into the wood. So how do we pull out the nail from the wood? Okay, it's very difficult. If we use our hand, it's very difficult. But we need to use any tool to pull out the nails. Okay, maybe people can use plier to pull out the nails. Okay, but the best way, we use the hammer to pull out the nail. Why? Because the hammer, we have the hook and then the handle, we turn the handle, so it's easy to pull out the nail, meaning we use the moment here. The longer the handle, the easier to remove the nail from the wood. Okay, our title today is moment. Okay, first our learning objective is define concept of moment in 2D, moment in scalar formulation, and then calculate moment in engineering problem. Okay, definition. Okay, definition. Moment is a tendency of a force to cause rotation about a point of around an axis. Okay, we always find the word moment, and the moment, but moment is different in engineering. Okay, moment in our language, maybe we say the time. A few time or brief time. So, but in engineering, a moment of force is tendency of force to cause rotation about point or around axis. Okay, look at this picture. Okay, we look at this is spanner. Okay, what's a spanner? This is a piping spanner. Fiber. Okay. It's very difficult to we turn the bolt or nut with our hand. But when we use the spanner, the spanner have a distance from the bolt. I mean, the longer the distance, the easier to move. And then the longer the distance, the higher the moment. Okay. Okay, we look to another slide. Okay, what is moment? Okay, the moment M of force about a point provide a measure of the tendency for rotation, sometimes called a torque. Okay, maybe the previous subject and in physics you have learned about torque. You know, torque is a force multiplied by distance. But mostly torque is used in a spinning system, like a wheel, called gear, and we use torque. But in static system, in a static in mechanic, we are in a what we call for the beam or the arm, the static condition, we always say moment. Okay, the moment of force about point provide a measure of the tendency for rotation. That means maybe it's not rotate, but the tendency for rotation. The direction of MO is either clockwise or counterclockwise. Clockwise like this, clockwise or counterclockwise. So depending on the tendency for rotation. Okay, we go to the next slide. Okay, now, the formula. Okay, the formula for moment is very simple. Force time distance. Force, is force time distance. But make sure the distance must perpendicular distance. Must perpendicular distance. Okay. Okay, we go to the next slide. The units of moment. Okay, the unit of moment are Newton meter. Newton, same like a torque, also Newton meter in SI unit. Okay, explanation. Okay, force F tend to rotate the beam clockwise about with moment. It's a beam. Here is beam. If we learn civil engineering and mechanical engineering, we always find beam, bridge, beam, roof beam, and another beam, ground beam. Okay. So force F tend to rotate the beam clockwise about A with a moment ma. Okay, here is point A. So force M tend to rotate, rotate to clockwise, rotate to clockwise with a moment ma, and we calculate force time distance. dA is from here, from A to the force. Make sure we take the perpendicular distance. Okay. Right. Okay, for F tend to rotate point B. So this force tend to rotate the beam counterclockwise like this. Lawan jam. Counterclockwise. So the formula FB is equal to F dB. Okay, F we multiply by distance from force to the point B in perpendicular, perpendicular distance. Okay. Hence support A and B prevent the rotation. Okay, we go to the we try to look to the example. The moment is the simple topic. Okay, this is a basic for you solve the problem about equilibrium of rigid body. What else? We want to find the reaction on support. We can use the moment, but the basic we have to know how to calculate, how to determine the moment. Okay, this is question. This is the example for question for the moment. Okay, we look to the first problem. Okay, it's a very simple question. Okay, we look, this is a fixed support, fixed support. Okay, beam in as a fixed support. So the distance from the point O from the wall is 2 meter. Okay, and then force applied at the end of this beam is 100 newton. Okay, only two parameter. Only two parameter, but you make sure the distance must perpendicular. Okay. So how to calculate? Ah, okay, the formula MO is equal FT, force time distance. So 100 multiplied by 2 is equal to 200 Newton meter. Okay, the unit is Newton meter and the direction is clockwise. The direction is clockwise. Okay, okay, this is the symbol for direction. It's turn clockwise. Okay, we look to another question. Okay, maybe more complicated than the first question. All right, we look at this system, this beam. Okay, it also fixed into the wall. Okay, so the distance is 2 meter from the wall, and then we bend perpendicular 90 degree. We bend 90 degree, and then the distance of bend is 0.75 meter. But the force applied is not vertical. Force applied 50 and 50 Newton is horizontal. It's not vertical. Like previous question. And this is a horizontal force. Okay, how to get the moment? Determine the moment for this system. Okay, so we have to remember, the moment is force multiplied by perpendicular distance. Moment is force multiplied by perpendicular distance. Is the formula. Okay, we look to the solution. Okay, the solution. Okay, so picture. Okay, so we cannot take 50 plus 2. Cannot. Why? 2 is not the perpendicular distance. 2 is parallel to the force. It's not possible. It's not possible. So we need to take the perpendicular distance. Perpendicular distance is 0.75. Okay, so the answer 50 multiplied by 0.75, so we get 375 Newton meter. Okay, how we determine it clockwise or counterclockwise? Some students, how to determine clockwise or anti-clockwise? I cannot understand. Okay, it's very simple. Okay, here is the point of rotation. The point of rotation. We connect the force here. Right. We connect the force, so we get here is perpendicular. Okay, so perpendicular here. Perpendicular distance is here. So we can take 0.75 meter. Okay, and then we imagine that the arrow it transfer. We move here. Okay, we shift to here, and then where the force want to rotate, clockwise or counterclockwise. For this arrow, we refer to the point O here. Definitely, if we return, we will turn in clockwise. Clockwise. This blue color is the answer. This is not couple moment. Some people say this is a couple moment. No, this is not couple moment. This is the answer for this is a moment. Total moment. Okay, we look to the another question. All right. Okay, this system. Okay, for question C. Okay, this arm and 4 meter is pin with a bracket here, and then bend 30 degree. Bend 30 degree, and the distance is 2 meter here. Okay, and the force applied here is 40 Newton. Okay, so the question is determine the moment. Okay, I have told you that we want to calculate the moment, we must take force multiplied by perpendicular distance. So we cannot, okay, for 40, example, we take 40, 40 times 4 plus 2. It's wrong. Okay, absolutely wrong. Cannot. We have to take the perpendicular distance. Okay, perpendicular distance is 4 meter plus 2 cos 30 degree. How we get 2 cos 30 degree? Okay, here is 2 meter. The length is 2 meter, and here the angle is 30 degree. So we assume this is adjacent and this is hypotenuse. Okay, so adjacent per hypotenuse. Okay, we assume here is x. Okay, x is adjacent. X, very difficult. X per 2 meter. So adjacent per hypotenuse, we will get cos 30 degree. So x equal to 2 cos 30 degree. Alright. Okay. So how to calculate the moment, how to get the answer? Right. Okay, very simple. So 40 is a force, moment, formula. We write the formula again. We need to remember, again and again. So we will remember the formula. Force multiply. We always put dot. Dot is also multiply. Some people confuse. When we put cross, they say this is a cross product. Okay, so it's not cross product, it's not dot product. This is multiply and multiply by d. D is perpendicular distance. So perpendicular distance is 4 plus 2 cos 30 degree. Okay, so the answer is 229.228 Newton meter, and rotation is in clockwise. Okay, clockwise. Some people are confused. I always said, I told my student to determine clockwise, you try to connect. Example, you connect the arrow and the point with one string. Uh, you cannot connect arrow and oh, we cannot perpendicular. Never mind. We connect, and then we make sure where the force want to rotate, clockwise or counterclockwise. So we can assume that this is clockwise. Okay, we go to another question. Oh, it's more complicated, but don't worry. We just assume moment is force multiplied by perpendicular distance. Okay, so is it 3 meter perpendicular distance? Absolutely not a perpendicular distance. So perpendicular distance is here. Okay, when we refer to the point O, so the perpendicular distance is here. Okay, so perpendicular distance here is 1 meter, and then the angle is 45 degree. So how we get it? So opposite per hypotenuse sine, 1 sine 45 degree. Okay, so the solution 60 meter, okay, multiplied by perpendicular distance. Okay, some people how to get perpendicular. Nanti we connect. We connect with the rotation point. Okay, rotation point. This here is perpendicular. Okay, perpendicular distance. Okay. So we get the answer 42.43 Newton meter, and the rotation in counterclockwise. We connect the one string, so it will turn counterclockwise. Okay. So we go to another question. Okay. This system, the height is 4 meter. 4 meter from rotation point, and then bend 2 meter another, and bend another perpendicular. Okay, 1 meter. Okay. So what is the perpendicular distance from the applied force? So applied force is 7 kilonewton horizontal. Okay, where the perpendicular distance? So we cannot take the 4 meter, we cannot take 2 meter, we cannot take 1 meter, but the perpendicular distance is here. Okay, perpendicular distance 7 kilometer. Okay, so the moment is 7. Sorry. The moment is F multiplied by perpendicular distance. So 7 kilometer multiplied by what distance? Okay, so 4 meter minus 1. So ini we multiply by 3 meter only. Okay, so we will get 21 kilo. Make sure your units must correct. We put the correct unit. If we give the kilonewton, the answer must kilonewton. Okay. Alright. Okay, we skip. Alright. What is this? Okay. This is biscuit tin. Eh? It's very difficult to us to open the cover of biscuit tin, unless we use the spoon. Spoon as we act as a lever, so we can open this cover. Okay, this is concept of moment. Okay, we look at another picture. Oh, this is our problem. This is our problem. When we drive a car, and then sometimes the tire puncture. Okay, so we need to do ourselves, to change the tire. So how to remove the tire? We want to change the spare tire. So we need to open to loosen the nut. We cannot lose the nut by our hand. We need to use the spanner. And sometimes we cannot. We have to step on the spanner. We step on this spanner to open to loosen the nuts. Okay, but you have realized we will use the what we call concept of moment. Okay, the longer the handle, so it's easier to open the nuts. Okay. Okay, thanks. Okay. So any question? You write on the comment. Okay. Again, or you can see your lecture. You ask your lecture, your tutorial lecturer, the practical lecturer. All right. Okay, this is the end of lecture. Get more information about principle of moment topic in website. Make sure you type moment of force. It's the different moment of another things. Okay, moment about the time, about the importance, and the moment is about a moment of force. Okay, this is physics. This is also physics. Physics subject. Okay, thank you. So our what we call kata-kata hikmah. Okay. Auzubillahi minasyaitonir rajim. Wa qur rabbi zidni ilman. Dengan berkata, wahai Tuhanku, tambahilah ilmuku. Surah Toha ayat 114. Jadi we'll always praise to Allah. My Lord, please increase my knowledge. Okay. Please increase my knowledge. Okay. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Don't forget to attendance, kehadiran kuliah. Jangan lupa kamu daftarkan kehadiran kuliah kamu di dalam link yang telah diberi dalam kamu punya Telegram. Sekian saja.